Hello everyone, in this video I'm going to discuss the example for limits and continuity. Given we have the function fx where we have modulus x plus 1 over the x plus 1 plus with the 5x. Find the limit when x approaching the negative 1 from the right and find the limit when x approaching negative 1 from the left for the function fx. Is f continuous at x is equals to negative 1? Give your reason. So before we begin, let's define the situation. We have the modulus of x. So we have the positive x plus 1, we have the negative bracket x plus 1. Domain x plus 1 greater equals to 0, x plus 1 less than 0. So that is the definition. So we have the x plus 1, x greater equals to negative 1, we have the negative bracket x plus 1, then we have x less than negative 1. So represent the situation in a real number line, we have the negative 1. On the left hand side we have negative bracket x plus 1. On the right hand side we have x plus with the 1. So refers to the situation, limit when x approaching negative 1 from the left. So focus on the situation from the left, so meaning that this part. We have the negative bracket x plus with the 1 over x plus with the 1 plus with the 5x. So limit when x approaching negative 1 from the left. So we have the negative 1 plus with the 5x. So kindly substitute, and here we have the value of y approaching negative 6. Continue. Limit when x approaching negative 1 from the right. Refers to this part from the right. So we have x plus 1 over x plus 1 plus with the 5x. So limit when x approaching negative 1 from the right. We have 1 plus with the 5x where we have the value of y approaching negative 4. So that is the limit for x approaching negative 1 from the left and also x approaching negative 1 from the right for the function fx. So since limit when x approaching negative 1 from the left for the function fx is not equals to limit when x approaching negative 1 from the right for the function fx, then we can say limit when x approaching negative 1 for the function fx does not exist. So the second question is the f continuous at x is equals to negative 1. So refers to the situation number 1, f bracket negative 1. So kindly substitute the situation. So if we substitute negative 1, we are going to refer to this part because we have the equals to the negative 1. So meaning that we have the x plus to the 1 over the x plus to the 1 plus with the 5x. So f bracket negative 1 where we have the 1 minus the 5. So the value of y will be approaching negative 4. So that is the first situation. For the second situation, limit when x approaching negative 1 for the function fx does not exist. So from here we can say fx is not continuous at x is equals to negative 1. So kindly refers to B. The continuous function f is defined as follow. So here we have the number line a. X less than a. So here we have 2x squared plus with the 4x. X greater equals to a. So here we have negative x plus with the 7. So here we have the situation given. Find the value of a if a greater than 0. Hence, sketch the graph of fx using the value a. So here they mentions that it is continuous. So meaning that limit when x approaching a from the left, which is equals to limit when x approaching a from the right. So kindly substitute the function. We have the 2x squared plus with the 4x, and then here we have negative x plus with the 7. So kindly substitute. We have 2a squared plus with the 4a equals to negative a plus with the 7. 2a squared plus with the 5a minus the 7 equals to 0. Kindly factorize the situation. So here we have 2a plus with the 7, and then we have a minus the 1 equals to 0. So a is equals to negative 7 over 2, a is equals to 1. So since a greater than 0, so a equals to 1 would be the situation satisfy the equation. So now we are going to sketch the graph. So focus on the left hand side. we have the 2x squared plus with the 4x. So step number 1, we have the U shape. Second step, find the x-intercept when y is equals to 0. So here we have 2x squared plus with the 4x equals to 0. So 2x bracket, we have x plus with the 2. So we have x is equals to 0, x is equals to negative 2. So we have the point for the x-intercept 0, 0, negative 2, 0. Then we have the y-intercept when x is equals to 0. Then the value of y also equals to 0. Third step, we have the standard form. So y is equals to 2 bracket, we have the x squared plus with the 2x. So 2 bracket, we have the x squared plus with the 2x plus bracket, we have 1 squared minus 1 squared. So 2 bracket, we have x plus with the 1 square minus the 1. So 2 bracket, x plus 1 bracket square minus the 2. So we have the minimum value, where we have negative 1, negative 2. We have the symmetrical axis, x is equals to negative 1. Next, focus on the graph. We have the 0, 0. Then we have negative 1, negative 2, 0. So done for this part. Next, we have the minimum point, negative 1, negative 2, negative 1, negative 2. So we have the symmetrical axis. So kindly sketch the graph. So refers to this part, we only have until 1. So if we substitute the 1, then the value of y will be 6. So the graph will be something like this. So that is the graph of y is equals to 2x squared plus with the 4x for the situation x less than 1. So here remember we have the empty circle. Next, continue, we have to sketch the graph for the negative x plus with the 7. So if we substitute the 1, then we have the value 6. So continue. If y is equals to 0, so we have y equals to negative x plus with the 7. So when y equals to 0, then we have negative x plus with the 7. So x is equals to 7. So we have 1, 2, 3, 4, 5, 6, and 7. So the graph will be something like this. So that is the graph y is equals to negative x plus with the 7. So here we have the coordinate 7, 0. So here we have the coordinate 1 and 6. So here we have the coordinate negative 2, 0. Then here we have negative 1, negative 2. So that is the graph for the function fx. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.